Good afternoon all. നമ്മൾ ലാസ്റ്റ് ഡേയിൽ ഡബിൾ ഇൻ്റഗ്രേഷനും അത് വെച്ചിട്ടുള്ള തിയറംസുമാണ് കഴിഞ്ഞത്. ഈ സെക്ഷനിലുള്ളത് ട്രിപ്പിൾ ഇൻ്റഗ്രൽസ് ആണ്. ട്രിപ്പിൾ ഇൻ്റഗ്രൽസിനും ഡെഫിനേഷൻ നമ്മൾ റീമാൻ സമ്മിൽ ഡിഫൈൻ ചെയ്ത പോലെ തന്നെയാണ്. നമ്മൾ വി ഹാവ് എ ഫംഗ്ഷൻ ലെറ്റ് എഫ് ഓഫ് 3 വേരിയബിൾസ് ഡിഫൈൻഡ് ഓൺ എ ക്ലോസ്ഡ് റീജിയൻ ഡി ഓഫ് 3-dimensional space. Then the triple integral of f over d is given by triple integral over d f of x y z dv is equal to limit norm p tends to 0 summation k equal to 1 to n f of x k star y k star z k star delta v k. When f is continuous over d, the limit in 1 exists, then f is integrable over d. നമുക്ക് ഡബിൾ ഇൻ്റഗ്രൽ ആയിരുന്നപ്പോൾ 2 വേരിയബിളിലായിരുന്നു സമ്മേഷൻ. ഇവിടെ ട്രിപ്പിൾ ഇൻ്റഗ്രലാണ്. അപ്പോൾ 3 വേരിയബിളിൽ സമ്മേഷൻ ചെയ്യുക. ആഫ്റ്റർ ദാറ്റ് ഇൻ്റർവെൽ നോം പി ഇൻ്റർവെല്ലിൻ്റെ ലാർജസ്റ്റ് ലെങ്ത് ഷുഡ് ഗോസ് ടു 0. നൗ ദ ആപ്ലിക്കേഷൻ ഓഫ് ട്രിപ്പിൾ ഇൻ്റഗ്രൽസ്. We have if our function f of x y z equal to 1, then the volume of the solid d is given by v is equal to triple integral over d dv. നമ്മുടെ ഇനി if the density is 1, then the mass of the solid is given by m is equal to triple integral over d rho of x y z dv. Next application is moments, first moments and second moments. So first moment is defined as mxy is equal to triple integral over d z rho of xyz dv, and mxz is equal to triple integral over d y rho of xyz dv, and mayz is equal to triple integral over d x rho of xyz dv. Now next definition is for center of mass. Center of mass is defined as x bar y bar z bar, where x bar is equal to m yz by m and y bar is equal to m xz by m and z bar is equal to m xy by m. Now the centroid, if the density is a constant, then the center of mass is called the centroid. Now we have to define the the second moments in terms of triple integral. So triple integral, the second moments or moment of inertia is defined as ix equal to triple integral over d y square plus z square rho of xyz dv. Iy is equal to triple integral over d x square plus z square rho of xyz dv. Iz is equal to triple integral over d x square plus y square rho of xyz dv. Now radius of gyration. Radius of gyration is square root of r is equal to rg is equal to square root of I by m. Now we have a problem to find the volume of a solid. Problem is find the volume of the solid in the first octant bounded by the graphs of z equal to 1 minus y square, y equal to 2x and x equal to 3. So the volume is triple integral over d dv. Here the variation of z is from 0 to 1 minus y square and x varies from y by 2 to 3, y varies from 0 to 1. So the integral is integral 0 to 1, integral y by 2 to 3, integral 0 to 1 minus y square dz dx dy. So it becomes integral 0 to 1 y by 2 to 3. When we integrate with respect to z, the value is z within the limit 0 to 1 minus y square dx dy. 0 to 1 y by 2 to 3. If we apply the upper limit 1 minus y square, it becomes 1 minus y square and the lower limit is 0. So 1 minus y square into dx dy. Now we have to integrate with respect to x. Then 1 minus y square is constant, we can take outside. Integral dx is x within the limit y by 2 to 3 dy. So it becomes integral 0 to 1 minus y square into 3 minus y by 2 dy. Now when we expand the 1 minus y square into 3 into y minus 2, we will get 3 minus y by 2 minus 3y square plus y cube by 2 into 3. So it becomes 3y minus y square by 2 minus 3y cube by 3 plus y raised to 4 by 4. So y square y cube by, here only 2 is there, y square into y by 2 is y cube by 2. So y cube by 2, y raised to 4 by 4, 1 by 2 into y raised to 5 by 4. So the answer is 3 into, when we applied the upper limit 1, we get 3 minus 1 by 4 minus 3 by 3 plus 1 by 8, and when we take the LCM as 8, the answer is 24 minus 2 minus 8 plus 1, which is equal to 15 by 8 is the answer. Next problem is change the order of integration in integral 0 to 6, 0 to 4 minus 2x by 3, 0 to integral 0 to 3 minus x by 2, 3y by 4, f of 3 by 4y, f of x, y, z, dz, dy, dx. അപ്പോൾ നമുക്ക് ഇതിൻ്റെ ഓർഡർ ഓഫ് ഇൻറ്റഗ്രേഷൻ ഡി സെഡ് ഡി വൈ ഡി എക്സ് എന്നുള്ളത് മാറ്റി ചെയ്യാം. അപ്പോൾ ആദ്യം നമ്മൾ ഫോർ ദ ഫസ്റ്റ് വി ഹാവ് ടു ഫൈൻഡ് ദ സോളിഡ്സ് എക്സ്പ്രഷൻ. Here solid is bounded by the plane z equal to 3 minus x by 2 minus 3 by 2y. So not 3 by 2, 3 by 4y. When we take the LCM, so it becomes 4z is equal to 12 minus 2x minus 3y. So we can write 2x plus 3y plus 4z equal to 12. So y we can write, from the expression we can write 12 minus 2x minus 4y by 3, which is equal to 4 minus 2 by 3x minus 4 by 3y. Now, so we got one variable's limit 0 to y's limit 0 to 4 minus 2 by 3x minus 4 by 3y. Now put y equal to 0. So the expression is 2x plus 4z equal to 12. Then x equal to 12 minus 4 by 2, 4 by 4z by 2, which is equal to 6 minus 2z. Now we can put is x equal to 0. So 4z equal to 12. So z equal to 3. So the lower limit is 0. Therefore the limit from 0 to 6, 0 to 4 minus 2x by 3, 0 to 3 minus x by 2 minus 3 by 4y, f of x, y, z, dz, dy, dx becomes integral 0 to 3, 0 to 6 minus 2z, 0 to 4 minus 2 by 3x minus 4 by 3y, f of x, y, z, dz, dy, dx, dz. Next is the expression of cylindrical coordinates. So first we have to expression to convert rectangular coordinates x, y, z to cylindrical coordinates r, theta, z. R is equal to square root of x square plus y square. Theta equal to tan inverse y by x, and z equal to z itself. For the reverse process to convert cylindrical coordinates r, theta, z to cylindrical coordinates x, y, z, put x equal to r cos theta, y equal to r sin theta, and z equal to z. So we have a problem. Convert 8 pi by 3 7 in cylindrical coordinates to rectangular coordinates. And the next problem is convert minus root 2 1 in rectangular coordinates to cylindrical coordinates. So we can do the first problem, third problem first. So in the first problem, r is equal to 8, theta equal to pi by 3. So x equal to r cos theta, which is equal to 8 into cos pi by 3, which is equal to 8 into 1 by 2 equal to 4. Y equal to r sin theta, which is equal to 8 into sin pi by 3, which is equal to 8 into root 3 by 2, which is equal to 4 root 3. And z equal to z itself, which is equal to 7. Therefore, x, y, z, the point in rectangular coordinates x, y, z equal to 4 root 3, 7. Now, in the second problem, we have the expression in rectangular coordinates is minus root 2 root 2 1, that is x equal to minus root 2, y is equal to root 2, z equal to 1. So r square equal to x square plus y square, which is equal to minus root 2 all square plus root 2 all square equal to 2 plus 2 equal to 4. Therefore r equal to 2. Tan theta is equal to root 2 by minus root 2 equal to minus 1. Therefore theta equal to 3 by 4. Here r sin theta is greater than 0 and r cos theta is 1 is y is equal to, here r cos theta is less than 0. Some error is here. That's why theta equal to 3 pi by 4. Therefore r theta z is equal to 2 3 pi by 4 1. Fifth problem is, a solid in the first octant has a shape determined by the graph z equal to square root of x square minus y square and the planes z equal to 1, x equal to 0 and y equal to 0. Find the center of mass if the density is given by rho theta z is equal to r. So here the density is given in cylindrical coordinates, so we have to convert the expression. We have the mass expression in the applications in the triple integral over d rho of x y z dz. So we have to convert that into cylindrical coordinates. When we have so m is equal to triple integral over rho x of x y z dv, and when we convert that thing into so rho of x y z equal to r, when we convert the cylinder from rectangular coordinates to cylindrical coordinates, we have a multiple of r in that. Triple integral over d r into r dz dr d theta. So in cylindrical coordinates, the range of r varies from 0 to 1, theta varies from 0 to pi by 2, and z varies from r to 1. So therefore m is equal to integral 0 to pi by 2 integral 0 to 1 integral r to 1 r square dz dr d theta, which is equal to integral 0 to pi by 2 integral 0 to 1 r square into z within the limit r to 1 dr d theta, which is equal to integral 0 to pi by 2 integral 0 to 1 r square into 1 minus r dr d theta, which is equal to 0 to pi by 2 integral 0 to 1 r square minus r cube dr d theta. So the integration is from 0 to pi by 2. Integral of r square is r cube by 3 and integral of r cube is r raised to 4 by 4 within the limit 0 to 1 d theta, which is equal to integral 0 to pi by 2. When we put 1, substitute 1, it becomes 1 by 3 minus 1 by 4. We can take the LCM of that, and so the value becomes 12 in the denominator and numerator for minus 3. So the answer is 1 by 12. So therefore the integral is from 0 to pi by 2 1 by 12 d theta. So when we integrate with respect to theta, 1 by 12 is constant. We can take outside. Integral of d theta is theta within the limit 0 to pi by 2, which is equal to 1 by 12 into pi by 2. So the answer becomes pi by 24. To find the center of mass, we have to find the first moments mxy, myz and mxz. The expression of mxy is triple integral over d z r dv. R is the density, z into rho is r. So which is equal to, when we convert this expression into cylindrical coordinates, we will get one more r in the integrand. So the equation becomes integral 0 to pi by 2 integral 0 to 1 r to 1 z into r square dz dr d theta, which is equal to integral 0 to pi by 2 0 to 1 r square into integral of z is z square by 2 from r to 1 dr d theta, which is equal to integral 0 to pi by 2 integral 0 to 1 r square into 1 by 2 minus r square by 2 dr d theta, which is equal to integral 0 to pi by 2 integral 0 to 1. We can multiply the r square into the term 1 by 2 minus r square by 2. So it becomes r square by 2 minus r raised to 4 by 2 dr d theta, which becomes integral 0 to pi by 2 1 by 2 into integral of r square is r cube by 3 minus 1 by 2 into integral of r raised to 4 is r raised to 5 by 5 within the limit 0 to 1 d theta, which is equal to integral 0 to pi by 2 1 by 6 minus 1 by 10 d theta. The LCM is 30. So integral 0 to pi by 2, when we take the LCM as 30, numerator becomes 5 minus 3, which is equal to integral 0 to pi by 2 2 by 30 d theta. 2 by 30 is 1 by 15 into pi by integral 0 to pi by 2 d theta is theta, theta within the limit pi by 0 to pi by 2, so it becomes pi by 2. So 1 by 15 into pi by 2, which is equal to pi by 30. Now mxy is equal to triple integral over dy into rho of xyz dv. We have to convert it into cylindrical coordinates. So y is equal to r sin theta into rho of xyz is r. When we convert the dv expression in cylindrical coordinates, 1 r is there, r d is there, dr d theta. So it becomes integral 0 to pi by 2, integral 0 to 1, integral r to 1, r cube sin theta dz dr d theta, which is equal to integral 0 to pi by 2, integral 0 to 1, r cube sin theta z into r to 1 dr d theta, which is equal to integral 0 to pi by 2, integral 0 to 1, r cube sin theta. When we substitute 1 and r, it becomes 1 minus r dr d theta. We can multiply the 1 minus r to r cube sin theta. So the integral becomes integral 0 to pi by 2, integral 0 to 1, r cube sin theta minus r raised to 4 sin theta dr d theta. Is equal to integral 0 to pi by 2 sin theta we can take outside, r raised to 4 by 4 minus r raised to 5 by 5 within the limit 0 to 1. So d theta, which is equal to integral 0 to pi by 2 sin theta into 1 by 4 minus 1 by 5 d theta, which is equal to integral 0 to pi by 2 sin theta. Then we can take the LCM as 20. 5 minus 4 d theta, which is equal to integral 0 to pi by 2 sin theta into 1 by 20, which is equal to 1 by 20 into integral sin theta is minus cos theta within the limit 0 to pi by 2, which is equal to 1 by 20 into integral 0 to minus 1 equal to 1 by 20. Similarly, we can find myz is equal to 1 by 20. In the expression, we have triple integral over dx into rho equal to r dv. So x equal to y cos theta. We have to substitute in this. We have the same integral instead of sin theta. We have cos theta. So the expression is the final value is 1 by 20. Now the center of mass is equal to x bar, y bar, z bar, where x bar equal to myz by m, which is equal to 1 by 20 by pi by 24, approximately equal to 0.38, and y bar is equal to m is xz by m, which is equal to 1 by 20 by pi by 24, approximately again equal to 0.38. Z bar equal to mxy by m, pi by 30 by pi by 24, approximately equal to 0.8. Next we have the spherical coordinates. To convert spherical coordinates to rectangular coordinates, put x equal to rho sin phi cos theta, y equal to rho sin phi sin theta, and z equal to rho cos phi. And to convert cylindrical coordinates to spherical coordinates to cylindrical coordinates, put r equal to rho sin phi, theta equal to is theta itself, z equal to rho cos phi. So we have a problem. Convert 6 pi by 4 pi by 3 in rectangular coordinates and to, not in spherical coordinates, cylindrical coordinates. So to get the answer, we have here rho equal to 6, theta equal to pi by 4, theta equal to phi equal to pi by 4, theta equal to pi by 3. So in rectangular coordinates, x equal to rho sin phi cos theta, which is equal to 6 into sin pi by 4 into cos pi by 3, which is equal to 3 into 1 by root 2 into cos pi by 3 is 1 by 2. So we can cancel 2. So 3 by root 2. In the denominator 1 root 2 is there. So we can multiply root 2 to both numerator and denominator. So the answer is 3 root 2 by 2. Now y is equal to rho sin phi sin theta, which is equal to rho equal to 6 sin pi by 4 sin pi by 3, which is equal to 6 into 1 by root 2 into root 3 by 2. We can cancel 2, so 3 root 3 by root 2. Now we can multiply with numerator and denominator by root 2. So the term is 3 root 6 by 2. Now y, sorry, not y, z equal to rho cos phi, which is equal to 6 into cos pi by 4, which is equal to 6 into 1 by root 2. We can multiply the root 2 to numerator and denominator. So 6 by root 2 into root 2 by root 2, which is equal to 6 by 2 root 2, which is equal to 3 root 2. Therefore, the given spherical coordinates in cylindrical coordinates as we can write it 3 by 2 root 2, 3 root 6 by 2 and 3 root 2. Now to convert to spherical coordinates, cylindrical coordinates, put r equal to rho sin phi, theta equal to theta itself, z equal to cos phi. So r equal to 6 sin pi by 4, which is equal to 6 into 1 by root 2, 6 by root 2 into root 2 by root 2, which is equal to 6 by root 2 by 2, which is equal to 3 root 2. And when theta equal to pi by 3, theta is theta itself, which is equal to pi by 3, z equal to rho cos phi, which is equal to 6 into cos pi by 4, which is equal to 6 into 1 by root 2, which is equal to 6 root 2 by root 2 into root 2, which is equal to 6 root 2 by 2, which is 3 root 2. Therefore, in cylindrical coordinates, the given expression is 3 root 2 pi by 3, 3 root 2. Now we have an expression in cylindrical coordinates for triple integration. Triple integral over d f of rho phi theta dv is equal to integral from alpha to beta, integral from g1 theta to g2 theta, integral from f1 theta phi theta to f2 theta phi, f of rho theta phi, rho square sin phi, d rho d phi d theta. So we have to multiply a term rho square sin phi to convert the volume integral in spherical coordinates. Now we have a problem. Find the moment of inertia about the z-axis of the homogeneous solid bounded between the spheres x square plus y square plus z square equal to a square and h square plus y square plus z square equal to b when a less than b. So we have density is equal to here the cylindrical coordinates has the term rho. So here we use delta for the density. Therefore we delta rho theta phi equal to k, the constant density. Then I z is equal to triple integral over d integral over x square plus y square into k dv. Now we have to change it into spherical coordinates. So h square plus y square becomes rho square sin square phi and h square plus y square plus z square equal to rho square. Therefore here equation of sphere is rho equal to a and rho equal to b. Therefore the integration Iz, the inertia is equal to k from integral 0 to 2 pi, 0 to pi a to b rho square sin phi. When we change it into rho square sin square phi, and when we change it into spherical coordinates becomes into some rho square sin phi dr d phi d theta, which is equal to k into integral 0 to 2 pi integral 0 to pi a to b rho raised to 4 sin cube phi d rho d phi d theta, which is equal to k integral 0 to 2 pi integral 0 to pi integral of rho raised to 4 is rho raised to 5 by 5 within the limits a to b sin cube phi d theta, which is equal to k into integral 0 to 2 pi 0 to pi integral rho raised to 5 when we substitute b raised to 5 minus a raised to 5 by 5 sin cube phi d theta. Now we can take out the constant term b raised to 5 minus a raised to 5 by 5 to outside. Then it becomes k into b raised to 5 minus a raised to 5 by 5 integral 0 to 2 pi integral 0 to pi sin cube phi. We can to integrate we can change it to that sin square phi into 1 minus cos square phi into sin phi d theta. So it becomes k into b raised to 5 minus a raised to 5 by 5 integral 0 to 2 pi. When we multiply sin phi to inside, it becomes sin phi minus cos square phi sin phi. Here sin phi is there. Sin phi d theta cos square phi sin phi d phi d theta, which is equal to k into b raised to 5 minus a raised to 5 by 5 integral 0 to 2 pi. Integral of sin phi is minus cos phi. We have to take put cos phi equal to some u. So this becomes integral of minus integral of u square, derivative of cos phi is minus sin phi. So this becomes minus. So we have plus. So the integral is plus 1 by 3 cos cube phi 0 to pi d theta, which is equal to k into b raised to 5 minus a raised to 5 by 5 integral 0 to 2 pi. When we substitute for phi equal to pi, that becomes minus 1. So minus of minus cos phi is minus minus 1 plus 1 by 3 into minus 1 minus of minus 1 into 1 by 3 into minus 1 d theta. So k into b raised to 5 minus a raised to 5 by 5 1 minus 1 by 3 plus 1 minus 1 by 3. So 2 minus 2 by 3 is 4 by 3. So becomes k into b raised to 5 minus a raised to 5 by 5 into 4 by 3 integral 0 to 2 pi d theta, which is equal to 4k by 15 b cube b raised to 5 minus a raised to 5 into 2 pi, which is equal to 8k pi by 15 b raised to 5 minus a raised to 5.